name's Carl Lum. This is Trey Chaddick. We're going to talk about the LabKey development process. This talk is for external developers, non-LabKey developers, but it's also for clients or community that want some insight on how LabKey develops features and delivers them to everyone. So we're going to talk about sort of get into the nuts and bolts of how we go from feature ideas to actual working code to actually distributing them to a build near you. And then we'll also talk about future directions, what we are planning for later this year and also next year. So first, a little bit of context. For a company LabKey's size, we have a fairly large product team. And so the product team is the team that is focused on building and delivering features. So it's the largest organization within LabKey. So there's 15 developers, 4 testers, 2 PMs. Developers and testers, most of the folks in that role, their full-time job is to write code. And so for the 19.2 release, we had 619 pull requests. So we'll talk about this a little bit more in detail further into the talk, but a pull request is basically a unit of functionality that is planned or hopefully gets merged into a branch that we build our distributions from. So, and a pull request could be as simple as a single file with one line of code change, or it could be, hundreds of files with thousands of lines of code change. For 19.3, which is our current release, which we'll release in November, we will exceed that. We'll probably be north of 700 pull requests. So it's a lot of changes. It's very challenging as an organization to absorb that many changes and to keep the platform stable. But at the same time, we want to make changes. We want to get new functionality. So how do we do this in a maintainable and stable fashion? So about 6.5 years ago, we started experimenting with Git. And so you might ask, well geez, what took you so long? So a couple things. We had to, as an organization, we had to learn how to use Git, understand what works best for us, how we're going to move forward from Subversion to Git. But one big issue that we had was our legacy build system did not handle what we call transitive dependencies. And so we had to embark on a big project to migrate from Ant to Gradle. And this took a while because we had a lot of legacy code, a lot of legacy build scripts. We had to figure out what's the architecture for Gradle. So that took a while. We got past that, and that sort of unblocked us for moving forward to transition to Git. So as Adam mentioned in his talk yesterday, we've made a lot of major investments in SVN to Git migration this year. Early in the year, the team hit the ground running, and we did, I believe, 3 phases of Git migration. So the vast majority of our code has moved over from SVN to Git. So this year is really the first year that we've been able to take advantage of Git on a large scale and all of the workflows that it opens up for us. Also mentioned yesterday, the team sort of completed the transition from one agile methodology to another, Scrum to Kanban. I think the move to Kanban, it allowed us to move to more of a fluid mechanism to putting features on the board instead of sort of more of the, almost seemed less agile, the process that we had in place before. And so, also to shed some processes that were, holding the team up. So a lot of the results have been, we've been able to have increased stability on our branches, on trunk in particular. And this is a pretty big philosophical change from sort of software development in general, and also LabKey, where not very long ago, in our 4-month development cycle, we would see a lot of instability, especially in the early releases. And so we would move from destabilized builds, and we actually had the 4th and final month of our release cycle, we would dedicate a lot of time to stabilization. We actually called it the stabilization sprint. And so the shift has been more towards agile methodologies, and also gets us a little bit closer to continuous delivery, where the philosophy is that at any given moment, we feel that we can ship a build, and that is stable enough to deliver to our clients. Now, we're not entirely there, but that is sort of the aspiration that that we have. All of this work has allowed us to do larger refactors, make them more appealing, more approachable. And a lot of the reason for that has been the mechanisms for branching in Git. They're a lot lighter weight. A lot of times when we were in the under Subversion, the prospect of creating and maintaining a branch to do big foundational work was not super appealing, and so we would find reasons for not doing that. And so with Git, it's less of an issue. And so as an example, this year we've done provision sample sets, immutable table info, and these are things that Sample Manager needed, but also they benefited the whole platform. And so these are going to result in more stability, greater perf. And we've also done a number of security improvements for CSRF and HTML encoding. So with that, I'm going to pass it on to Trey.
Yeah, so I'm just going to give a high-level overview of how features go from conception to being included in the next release of LabKey. So this is a pretty high-level general process, and kind of in the spirit of Agile, is frequently adjusted based on varying requirements of different features. For example, a high-priority bug fix might skip straight from feature proposal straight to development, because it might be straightforward and fairly urgent. Or things might go from development and loop back to need refinement in their proposals if based on discoveries made during development. So first step of any feature is someone has to think of a feature, and those features are defined, might come from a support ticket or an internal platform initiative or premium functionality or some development contract. And the feature here is kind of a broad term, might refer to a huge project like Sample Manager could be, in some respects, the feature consists of many sub-features down to a simple bug fix. So we start with high-level requirements for that feature. The feature goes onto our company backlog, which is a whatever project management tool you use to keep track of incoming work, and we try to provide an initial high-level estimate of how long that work will take, and at this point might do initial breakup of a feature or epic in Kanban terminology into more manageable sub-projects. Periodically, the various sort of Kanban teams will groom their individual backlog to reprioritize as needed, refine estimates, reassign to other teams if need be, remove obsolete stories, all that sort of thing to keep the backlog up to date and relevant to the needs of users and LabKey. Once a new feature is ready to get more attention, we create a spec for the feature, which starts with requirements, which is high level what the feature should do. Functional design is how the feature accomplishes that. The implementation plan, which is how we make LabKey in particular accomplish those needs, and then a test plan to lay out how we'll verify that the feature does what we expect it to do. And as part of the specification, or shortly after, we'll divide the story into small bite-sized tasks that can be picked up by various developers for several reasons. One of them is like it's easier, and you can feel more confident in an estimate of a thing that you can say might take 3 hours versus maybe take 20 hours or a few days. It's very easy to miss things if you don't break it up into very specific tasks. So kind of expanding on what Carl was mentioning with Git, the feature branches, which eventually become pull requests. We use feature branches to develop features in isolation from each other, so different teams aren't stepping on each other's toes. And throughout the development, we have our continuous integration server running automated tests against that feature branch to make sure we hadn't broken any existing functionality. And then toward the end of development, a tester or project manager or someone that is responsible for the deliverable will do the manual testing according to the test plan from the spec. So the kind of life cycle of the pull request, usually around the time when a feature is ready for manual testing, someone will open a pull request, and it's a central location for developers and various people to view and discuss the proposed feature and different changes before they get merged back into the mainline branch. We use branch protection rules to minimize the risk of that feature breaking mainline functionality. The two sort of branch protection rules we use that GitHub provides, we require code reviews on every change, so we at least get multiple sets of eyes on something to make sure it conforms to coding best practices and functions as intended at a fundamental level. And we also, TeamCity reports build status back to GitHub periodically about almost every commit, but depending on if a few come in rapid fire, they might only get one later one. And then eventually, after the code review is complete and TeamCity shows all green, we merge that feature back into develop or release snapshot or wherever you have for kind of the final phase of validation to make sure it plays nicely with the rest of LabKey. And that's kind of where regression testing comes in. we have a pretty extensive set of regression tests that run nightly on our mainline branches. They take a bunch of them run in parallel, but it's over probably around 12 to 15 hours worth of integration tests run against all areas of LabKey. Any test failures that turn up are fixed, and new automated tests are written to cover the new functionality. Yeah, and then once the regression tests are in place, then they will continue to validate the functionality of that feature throughout the life of LabKey and that particular feature. And now that once the feature has been verified, regression tests are in place, and any breaks have been fixed, then it is ready for inclusion in the next LabKey release, which Carl will discuss.
Okay, so how do we get all this, great code that we've developed as part of feature development into a release, distribution for our clients? So for the historical types of releases, we've had sort of our major release, which has a cadence of every 4 months. So we do 3 releases a year. We've also had what we call sprint releases. These are monthly builds, monthly snapshots that we'll deploy internally. Some clients will take these to do internal testing for validation, or they want to look at perhaps a feature that we've developed for them. And then hot fixes are sort of post-release if we find sort of a critical, either a data or a security problem or fix that needs to go out, we'll go and push these out to the community. And then there's sort of this mysterious modules branch, which we've had historically, which were mostly intended for client-specific features that were only in their module that didn't necessarily touch core code, that we could sort of safely develop their feature while still being on the stable branch. So for a while, we were doing a very bad thing in our artifact naming, which was essentially the artifacts and the installers that we deliver, we name them the same, and they would have different code in them, which made it difficult for the services team and our clients to know, well, what's in this thing that is called 18.3, whatever. And so invariably, a developer would have to crack open the module, look at it, align the SVN number or the Git hash to the module that the code supposedly went into it to say, yes, you've got that fix, hopefully. So, overall, it's just difficult for the team to know, what changes are in a particular release. And so to fix that, we've adopted elements of semantic versioning. Semantic versioning is a specification for software versioning that implies, different things. We're not embracing all tenets of semantic versioning. Most of what we've adopted is the incorporation of the patch number, so that the last number at the end. And so for comparison, we can sort of look at what we were doing before and after. And so for all of our historical types, we were naming them the same, which was a problem. And now we're moving to more of a, so for the foremost sprint builds, since we're not doing Scrum anymore, we call them alpha builds. They still occur at a monthly cycle, so that cadence hasn't changed. And then the release candidate is really the version that we create when create the release branch. So this is usually at the end of the final month of the release cycle, and then prior to about 2 weeks before we do the formal release. So we're trying to stabilize in that 2-week period. And then finally, the major release, the formal release from here on out will always be the .0 formal release. And then probably more interesting to everyone is the maintenance releases, formerly the hotfix releases. So the maintenance releases are something new that we've started to do this year. It's we plan for on average 6 per major release cycle. So the cadence is for the first 2 months, we will release we'll push one out every 2 weeks. And then the final 2 months, we'll drop back to a 3-week cadence. Of course, we're flexible, so 6 is sort of the minimum, and we'll do more if we need to. And we've done as many as 8 so far, and that's to push out, say, like a high priority client fix or a high priority security fix that we need to. So it feels like it gives us a pretty good balance between being responsive to the community and our clients while being building off of a stable base. So the other thing with not only the maintenance releases, but also the other formal releases, by going to a combination of semantic versioning adoption as well as our move to GitHub, is we can track our changes a little bit better. And so we've built an internal tool which allows the development team as well as the services team to look at the various releases and align that with the pull requests. So you can sort of look at all of the various release artifacts and then drill into them and look at, well, what are all the pull requests that are in them, and you can further, they're linked to the pull requests, so you can go and drill into them, and it takes you to GitHub, and you can see the actual files changed, you can see the code that was changed, you can see the comments that were made. So it gives us a really good tracking mechanism for knowing what is in and what is out. And I think it feels like this has been a pretty big win for not only the product team, but also the services team to communicate with our clients. Hey, this is for this maintenance release. It contains these things. Let us know if you're interested in deploying this. So for future directions, we want to obviously wrap up Git migration. So finish, as Adam mentioned yesterday, we're going to finish moving everything out of Subversion. So we'll have 0 Subversion footprint. Everything will be in Git. We also want to have better support for building against binaries or not building against source. And so I was talking to Anthony about this earlier. They are running into this, but if you're an external developer and you're developing your own module, you typically want to only have the source code of your own module, and you want to compile against a library of binaries. Right now, what you have to do is you have to enlist in the source code. And sometimes you may want to see the source code, but more often than not, you just want to build your module. And so we are making slow progress towards solving this. So I'm hoping that in the future, people will just be able to say, hey, I just want to build against this version of LabKey. Get me the jar files, and we'll serve them up from Artifactory. We've also, for a number of years, been incubating a new version of our JavaScript API. It's in GitHub right now. It is a TypeScript-based API. It's the plan is to bring it to feature parity with our existing JavaScript API, transition internally, and then make that available to our clients. So besides being TypeScript-based, it'll also allow us, because it's going to be versioned, it'll allow us to make sort of larger refactors without necessarily destabilizing our clients who use it. And finally, we will probably invest in additional tooling in our Gradle plugin to make it easier to enlist in various repositories, as well as like switch between various feature branches. Right now, a lot of that is manual, but there's been some progress towards that with the multi-git tool, but still a lot more things that we can do. So that is it for our presentation. Any questions? Well. Yes and no. I think so. The current JavaScript API, there's sort of a DOM and a non-DOM version. So it's like a part that assumes that you're in the browser, right? So the new version of the JavaScript API is all non-DOM, so it doesn't assume any browser. So I think we need to figure out exactly what this is going to look like, but I would envision that we will keep the DOM-based version, and it's a pretty small footprint right now that assumes browser or does like document or window. We'll probably keep that where it is, and then pull the rest of it out, and then pivot away from that so that we're using the GitHub-based one. Does that make sense?
You guys moved from previous processes to Git. What was like some challenges or some pushback that you got? How do you overcome those?
Yeah. So the question is sort of moving from previous processes to the Git and challenges and pushback. I'd say some of the challenges have been, of all the things that are possible, like what fits for your organization, and so striking the right balance between being super locked down, versus too lenient. I think we've had to flow things to the team, and our approach has been more incremental. And so, for example, the branch protection rules, those were things that we initially didn't adopt, but those are things that we've added on recently. And so, from our perspective, internally, the pushback has been pretty minimal. I think people wanted us to go, perhaps a little faster. I think from the client community, there's a little bit of pushback, and one example of that is so when external developers they want to develop against their module, when we said, well, you need to follow the feature branch workflow, and you need to do a pull request. Some things that we heard were like, well, I'm new to Git, and so I think having a minimal of restrictions would be better, which seems counterintuitive. But I'd say by far they were pretty minimal, and most people are pretty good about, like, they're more interested in having protection and stability, and being willing to sort of follow our lead. Yes. I don't know what that guy's talking about. No, that's true, because I think there's, within our team, there is a variety of Git expertise, and so, like, old people like me and Matt, like, we're like, oh, Git, what is that? So, I think it's been an education, so I think for your guidance for your organization is over-communicate and, lots of documentation, and we always, in our dev meetings, we have recurring training about, like, how best to use Git. Here's what to do if you encounter this. So Git is very powerful, and there's a lot of different ways to do the same thing, which can be super confusing. So yeah, educating your team is really valuable. Anthony?
You showed an example of an internal set of tables that say, okay, there's these feature ranges that got merged.
Yeah.
Would that be available public first in some form? So for example, I only get cache bases that are listed on the support form, which might be
Mm-hmm.
0 initial feature release. And it will list 3 what was there, but I don't know what was in 1 or 2.
Yeah.
Make that kind of publicly, what's going to do?
Yeah, I would say, do you want to address that, Avital?
Yeah, so the list we have right now, that Carl showed is sort of, it's internal because it's still kind of waiting for them, and so it's not, it hasn't been formatted for public facing, making sure that the commit comments are signed appropriately. Developers have more imagination than others. And so we are working through a way to then digest that and sort of fine tune the format. But if you, what the account managers do, so what Hannah would do in this case is we know everything that goes into a patch release, and she'll know if that's a fixable thing or not, and then she's going to be able to digest what's in there. Or you can ask for it.
Right, so I get it. I get the list for the
Okay.
Hannah for, say, I got 1 throughput, but I don't know what's in 1. Or, yeah, I don't know what's in 2. If I don't get it on my support form,
Right.
I don't, when I do the next one, you need to see what was in there.
Oh, yeah.
To see if there's other areas of code that need compression, manual compression, that makes sense.
Right. So we're we're working on getting it for public.
Other questions? Yes.
The answer for this might be, it depends, but do you have any prediction for like the timeline for rolling out newer features to, or like fixes to other new features like Sample Manager, for example? Like I know some things will be uploaded or upgraded in LabKey server before they migrate or get implemented in Sample Manager, biologics, or whatever it is. But what's the delay getting to different?
Right. So the hope, especially with the maintenance releases, where historically the hot fixes were for bugs, and we tended to not really put features in there. But a combination of the maintenance releases as well as the improved isolation of feature development has led us to put more features into the maintenance releases. And so for applications like biologics and Sample Manager, so biologics uses that mechanism to shorten the cycle between when our clients get biologics features as well as fixes. So I imagine that we're going to use a similar mechanism for Sample Manager to sort of fast track changes into the application. Now, some of that depends on where the fix is. So the team always tries to evaluate, like we always want to get features and fixes to the community and clients fastest, but it's always sort of a balance of like, well, what does the fix look like? Is it in the core code? How destabilizing is it? So we have to, when things are in the core code, there's sort of a greater chance that it might destabilize other portions of it. So there's different approaches where we can take, we'll take a more conservative approach to partially address it, and we'll do a bigger refactor in trunk. So I guess to answer your question, the desire and the intent is that, if we can, we're going to try to push more changes for Sample Manager out through the maintenance release. Any other questions? All right, thank you.